Hi everyone. Now we are performing an experiment, that is a RC time constant or a charging and discharging of a capacitor. That is how we are performing. As previously I have already made the connections. I will show the circuit diagram how to connect it. So these are the connections. The battery negative is connected to the plug key K, and battery positive is connected to the terminal K1, and the middle point tapping point is connected to the resistor R, and one terminal resistor R is connected to the, here I have made a junction. One terminal is connected to the capacitor positive, and another terminal is connected to the voltmeter positive. Then the voltmeter negative is connected to the capacitor negative, and from here I am making two wires, that is one wire is connected to the plug key K2 and another key K1. Sorry, not K1, it's K. And then I will show you the connections, and before that I will explain you the aim, that is to determine the time constant of a given RC circuit by plotting an instantaneous voltage across the capacitor versus time capacity with its theoretical values. Then the formula is time t is equal to R into C, so that it is called as RC time constant, and this is about the nature of the graph. And this graph shows for charging, and this is for the discharging. The junction between the charging and discharging, this point, this time is known as the time constant. And what I have to do is, before performing the experiment, I need to take for the readings for 30 seconds only. That is, the time difference is 30 seconds. Here also same 30 seconds. Then it comes around 120 seconds, like this, and corresponding voltage to that second. Here also same for discharging also. This is 0 seconds, 30 seconds, 60 seconds, 90 seconds, and continuously it takes up to 20 readings. While discharging, note on its readings. Then before that, the observations are the capacitance of the capacitor is 200 microfarad. So this is 200 microfarad, this one is 100 microfarad, and this one is 100 microfarad. Sorry, this one is 1000 microfarad, and this one is also 1000 microfarad. So that the combination of two capacitors is 2000 microfarad, and the resistance is 56 kilo. So you can see the color combination green, blue, and red, and the impedance is gold. So it is approximately 56, not approximately, it is 56 into 10 to the power of 3 ohm, that is 56 kilo ohm. And before that, I will just start the experiment by turning on this one. Yet initially again I will explain you the circuit once again. Battery negative is to the plug key, and one terminal is connected to the K2 terminal, and another key terminal connected to the junction between the voltmeter negative and the capacitor negative. Here I have made the connection, that is here only, and from that battery positive to plug key K1, is this one, and tapping point to resistor R. The tapping point to resistor R, and junction between the resistor and the capacitor is connected to one terminal of the voltmeter positive and voltmeter negative. Before starting the experiment, what I will do, I will connect the circuit by placing a key. At this time, there will be the connection are completely connected, and then if I close the plug key K1, then the capacitor gets discharges. You can observe that capacitor gets charges. It is increasing. And we know that the capacitor, without placing the key K1 and K2, the capacitor will not charge and it will not discharge. So before starting the experiment, what we need to do is, for charging condition, for this condition, what I need to do, at the same time, by placing the key K1, I need to start counting. I need to start count the time. That is, by placing K1, I need to start the stopwatch. that is for 15 seconds now, and it's 20 seconds, now it's 25 seconds, and for 30 seconds it is 0.75. Then what I need to do is, for 30 seconds it is 0.75, sorry, 1.75, 1.75, and for now I am taking for the 1 minute, that is 60 seconds, that is 2.31. For 30 seconds 2.31, next 30 seconds, that is 60 seconds, then for the 90 seconds. So continuously I have to take it for the charging purpose, and and now I will explain you about for the discharging purpose. Then for discharging I will keep it for the certain higher values, because it takes an infinite times to completely charges, because it will not be by placing a multimeter in the terminal of positive terminal and the negative terminal. I can see that I can say that it is not equal to 8 volt where I have applied 8 DC volts, but it will not equal to 8 DC volt. It will be approximately 11 volts, so in that range. So next what we need to do is keep it for charging until it takes some certain values. So up to that time, take the readings for the difference between 30 seconds. And now I left the capacitor for charging completely for a certain value, and by closing the K1 terminal, the capacitor gets charging, and by closing the K2, by opening K1 and closing K2, the capacitor gets discharging. So by this, so now what I will do is just you can observe that now the capacitor is completely charged, and it's not completely, it's partially charged. And then now I have opened terminals K1 and K2. Now by closing terminal K2, the capacitor starts discharging. Just you can observe it, and just suddenly start the timer. And take down for the 30 seconds. It was an initially 8.30 volts, and for next 30 seconds it will be decreasing, because now you are discharging the capacitor. This will be around 6.5 near, yes, 6.50, that is 6.50 volts. And for the next 30 seconds, that is for 1 minute, it will be 5 volt or little more than this, 5.2, 5.1, yes, 5.03, 5.03. So by taking all this reading up to 20 readings, I can plot a graph like this. For charging it will take this curve, and for discharging this curve, and later time constant t is equal to r into c, then r is equal to 56 into 10 to the power of 3 into 2000 into 10 to the power of minus 6. This is equal to approximately 11230 into 10 to the power of 3 into 10 to the power of minus 6, that is equal to 112 into, by again 123, it will be 10 to the power of 6 into 10 to the power of minus 6. This is equal to 112 second, approximately equal to 2 minutes. approximately equal to 2 minutes. Then this is the RC time constant theoretically. This is a calculation for theoretically, and this is for the practically. This is for the practically. ಇಲ್ಲಿ ಇನ್ ದಿಸ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ನಾವೇನು ಮಾಡ್ತೀವಿ ಅಂದರೆ, ಫಸ್ಟ್ ಆಫ್ ಆಲ್ ವಿ ವಿಲ್ ಕೀಪ್ ಇಟ್ ಫಾರ್ ಚಾರ್ಜಿಂಗ್. ಇಲ್ಲಿ ಈ ಕೀನ K1 ಕೀನ ಕ್ಲೋಸ್ ಮಾಡೋದ್ರ ಮುಖಾಂತರ ನಾವೇನು ಮಾಡ್ತೀವಿ, ಕೆಪಾಸಿಟರ್ನ ಚಾರ್ಜ್ ಮಾಡ್ತೀವಿ. ಚಾರ್ಜ್ ಮಾಡುವಾಗ ನಾವೇನು ಮಾಡ್ತೀವಿ, ಎವ್ರಿ 30 ಸೆಕೆಂಡ್ಸ್ ಆದಮೇಲೆ ಏನು ಮಾಡ್ತೀವಿ, ಇಲ್ಲಿ ನಾವು ಎಷ್ಟು ವೋಲ್ಟ್ ಬರ್ತಿದೆ ಬಿಟ್ವೀನ್ ದ ಟರ್ಮಿನಲ್ಸ್ ಆಫ್ ದ ಕೆಪಾಸಿಟರ್, ಈ ಪಾಯಿಂಟಲ್ಲಿ, ಈ ಪಾಯಿಂಟ್ ಮತ್ತು ಈ ಪಾಯಿಂಟ್ ಮಿಡಲು ನನಗೆ ಎಷ್ಟು ಕೆಪಾಸಿಟರ್ ಚಾರ್ಜ್ ಆಗ್ತಿದೆ, 30 ಸೆಕೆಂಡು ಟೈಮ್ನ ತಗೊಂಡು ಕೆಪಾಸಿಟರ್ ನನಗೆ ಎಷ್ಟು ಚಾರ್ಜ್ ಆಗಿ ಎಷ್ಟು ವೋಲ್ಟೇಜ್ ಬರ್ತಿದೆ ಅಂತ ಹೇಳಿ ಏನು ಮಾಡ್ತೀವಿ, ಫಾರ್ ಚಾರ್ಜಿಂಗ್ ಕಂಡೀಷನ್ಗೆ ನೋಟ್ ಆನ್ ಮಾಡ್ಕೊತ ಹೋಗ್ತೇವೆ. ದಟ್ ಈಸ್ ವಿ ಅಲಾಂಗ್ ದ. ನೆಕ್ಸ್ಟ್ ಏನು ಮಾಡ್ತೀವಿ, ಈ ಬಂದಿರೋ ವಿ ವೋಲ್ಟೇಜ್ನ ಅಲಾಂಗ್ ದ ವೈ ಆಕ್ಸಿಸಲ್ಲಿ ನಾವು ವೋಲ್ಟೇಜ್ನ ಪ್ಲಾಟ್ ಮಾಡ್ತೇವೆ. ದೆನ್ ಫಾರ್ 30 ಸೆಕೆಂಡ್, ಇವಾಗ 30 ಸೆಕೆಂಡಿಗೆ ಎಷ್ಟು ಬಂದಿದೆ, ಇಲ್ಲಿ ನಮಗೆ ಅರೌಂಡ್ 1.6 ಅಷ್ಟು ಬಂದಿದೆ. ದೆನ್ ಅಲ್ಲಿ ಎಷ್ಟು ಬಂದಿತ್ತು, ಸೊ 30 ಸೆಕೆಂಡ್ಸ್ಗೆ ನೆಕ್ಸ್ಟ್ ಎಷ್ಟು ವೋಲ್ಟೇಜ್ ಬಂತು, 30 ಸೆಕೆಂಡ್ಗೆ ಎಷ್ಟು ವೋಲ್ಟೇಜ್ ಬಂತು ಅಂತ ಈ ಕಡೆ ಬರೀತೆ. ನೆಕ್ಸ್ಟ್ ಡಿಸ್ಚಾರ್ಜಿಂಗ್, ಈ K1 ಏನಾದರೂ ನಾನು ಓಪನ್ ಮಾಡಿ K2ನ ಕ್ಲೋಸ್ ಮಾಡಿದೆ ಅಂದರೆ ನನಗೆ ಕೆಪಾಸಿಟರ್ ಏನಾಗುತ್ತೆ, ಡಿಸ್ಚಾರ್ಜ್ ಆಗಿ ಸ್ಟಾರ್ಟ್ ಆಗುತ್ತೆ. ಸೊ ಡಿಸ್ಚಾರ್ಜ್ ಆವಾಗ ಏನು ಮಾಡ್ತೀವಿ, ನೆಕ್ಸ್ಟ್ ಇಲ್ಲೇ ಸೇಮ್ ರೀತಿ ಮತ್ತೆ 30 ಸೆಕೆಂಡಿಗೆ ಎಷ್ಟು ವೋಲ್ಟ್ ಕೂಡ ಡಿಕ್ರೀಸ್ ಆಗ್ತಿದೆ, ಆ ಡಿಕ್ರೀಸ್ ಆಗ್ತಿರೋ ವೋಲ್ಟೇಜ್ ನಾವೇನು ಮಾಡ್ಕೊತ ಹೋಗ್ತೀವಿ, ಸೆಕೆಂಡ್ ಫೋರ್ತ್ ಕಾಲಮಲ್ಲಿ ಬರೀತೀವಿ. ದೆನ್ ಅದಕ್ಕೆ ನಾವು ಪ್ಲಾಟ್ ಮಾಡಿದಾಗ ಇನಿಷಿಯಲಿ ವೋಲ್ಟೇಜ್ ವಿಲ್ ಬಿ ಹೈ ಬಿಕಾಸ್ ಇಟ್ಸ್ ಕಂಪ್ಲೀಟ್ಲಿ ಫುಲ್ಲಿ ಚಾರ್ಜ್ ಆಗಿರೋದಕ್ಕೆ ಏನಾಗುತ್ತೆ, ನನಗೆ ಕಂಪ್ಲೀಟಾಗಿ ಬೇಗ ಇದು ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಇಲ್ಲೇನಾಗಿದೆ, ನನಗೆ ಇಲ್ಲಿ ಪಾಯಿಂಟಲ್ಲಿ ಕಂಪ್ಲೀಟ್ಲಿ ಚಾರ್ಜ್ ಆಗಿರುತ್ತೆ. ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ ದೀಸ್ 2 ಪಾಯಿಂಟ್ಸ್ ವಿಲ್ ಬಿ ಇನ್ ದ ಸ್ಟ್ರೇಟ್ ಲೈನ್. ಸಿಮಿಲರಾಗಿ ಎರಡೂ ಕೂಡ ನನಗೆ ಒಂದೇ ಪಾಯಿಂಟಲ್ಲಿ ಒಂದೇ ಪೊಸಿಷನಲ್ಲಿ ಇರುತ್ತೆ ಅಂತ ಹೇಳ್ಬೋದು.